Right, so let's continue with the steps of the cyber kill chain. And after seeing reconnaissance in the previous video, now we'll move to step 2, and that will be weaponization. So weaponization means that the attacker team found a weak point in the system and knows how to create an entry point in order to attack the system. To do that, they will design a virus or a worm that will target that specific vulnerability, exploit it, and then manage to enter the system and potentially gaining persistence and stealth within the system. Examples of weapons include botnets. A botnet is a network of computers that they kind of work together at the direction of a bot master. The bot master would actually instruct the botnet, the network, to actually do something, and that do something could be a denial of service attack. And since the bots will be geographically dispersed, the DOS attack will be a distributed DOS attack, where the bots are being used to flood a system or the network with data traffic, and the requests are so many that the system cannot handle them, and any new requests are being discarded and not responded to. So botnets can be used for DDoS attacks, and in this way you can ensure that some part of your system will be unresponsive, and you can use that to either to enter the system or to use it as a distraction to try to do some kind of another approach in order to mount an attack to the target network. Another weapon that's heavily used in OT attacks, because botnets and DDoS will create too much noise and are not that stealthy, and they can be detected easily and protected against. Mostly the weapons used for OT attacks will be malware, and will be mostly highly tailored malware to the system itself. So malware is software that is injected to the system to do things that the owner wouldn't want done. Worms, viruses, packet sniffers, logic bombs are all examples of malicious software that have been used one way or another to deliver an attack in both IT and the OT environment itself. So after the weapon has been created, for example, the malware, then this has to be delivered in step 3 of the cyber kill chain. So it has to be transmitted to the system, to the target, somehow. And this somehow can be email attachment. In Ukraine, Power Grid attack, it was an email attachment for spear phishing. It could be malicious websites. Havex malware was delivered with a drive-by attack by the operators visiting a trusted website that malware was placed. Or it could be removable media. That was a case of Stuxnet, where probably a USB drive was used to breach the air gap and install Stuxnet malware into the computers of the facility. The goal of the step is to somehow breach the system and establish a foothold. And to deliver the weapon, there are two basic methods. One would be that the delivery happens directly by the attacker. So you kind of hack into the system, you find an open port, you do some kind of exploitation in the process in order for you to physically copy the code to the system that you're trying to target. So this delivery, we say it's adversary controlled. If you cannot do it yourself, you may actually try to convince, or somehow through social engineering mostly, make a target do this for you. So in the case of removable media or the USB drive, someone took the drive and just put it in their laptop, and then the malware was delivered through this way. So this would be an example of adversary released delivery, that the malware is being conveyed through some kind of a social engineering effort. So you either try to deliver the malware yourself, or you try to convince or use someone else to deliver the malware for you. And that someone else would typically be someone with different credentials and access to the system. So now we deliver the attack, we deliver the weapon. Once the weapon is delivered, it has to be triggered somehow. And this trigger can be automatic or can be based on a specific action. And that will be step 4 in the cyber kill chain, exploitation. So as I already said, exploitation is triggering the intruder's payload, and it would typically target a vulnerability. For example, there's the SMB protocol in Windows has a specific vulnerability that when you send a well-crafted packet, this vulnerability can be exploited, leading to remote code execution. So one way of the step occurring exploitation would be to target the application, the operating system vulnerabilities. Or it could be the user themselves. For example, Stuxnet use the auto run feature of Windows, where if you insert some kind of removable media like CDs or USBs, then there will be some kind of automatic execution in order to aid in usability of the system. So it makes it easier for someone who's not very tech savvy to install software, because once you put the CD-ROM into the drive, then the auto run will automatically start something, the installation process typically, and then you will take it from there by clicking next. So exploitation can happen through either vulnerabilities or by using auto execution code features of the operating systems. Delivery exploitation can somehow be seen together. For example, the USB delivery exploits also the auto-run feature of Windows. But there are other things. User execution, you can somehow make the user deliver and run the code for you. Again, social engineering, as we saw in the past. Scripting is another method for delivery exploitation, where they use scripting languages to execute arbitrary code. And you can do JavaScript attacks, for example. If the operators visit malicious website, you can use the client-side scripting in order to do something malicious in the computer that you're targeting. Project file infection, you may put malware directly in the project file of the PLC or some other control logic in your system. So you can put the code in the project file and someone will put in the PLC, and now you have the attack delivered in the PLC itself. Man-the-middle attacks, so you modify network in real time. If you have some interaction with outside networks, you can intercept packets coming in and out of the organization you're targeting, and you can use that as a way to either do reconnaissance or to deliver and exploit some problem of the operating system of the target system. Graphical user interface, gain access to a machine via graphical user interface, VNC or remote desktop protocol. And we've seen examples of these attacks where, because you need the remote connectivity to a substation or some other part of your operation technology system, and these are typically only protected by a single password, then if you find that password, you automatically have access to that part of the network. That would be most probably in the operation technology part. And the last one would be command line interface method. To utilize that to interact with systems, maybe they left an SSH port open or Telnet one for some reason, either it was a mistake or they have them open for debugging or for the vendor to have access for updating the firmware or for checking for problems. So you can use those command line interfaces to deliver and trigger the exploitation of the weapon you have sent. So after exploitation takes place, then you have to ensure that the malware is installed in the system. In case of, for example, of a reboot of the system, then malware may disappear. So you have to ensure persistence of the malware on the target. So that will be stage 5, installation. And at this stage, you somehow install a remote access Trojan or a backdoor that allows you to maintain persistence. And doing that can be either can be done automatically through the exploitation. The malware itself, like Stuxnet did, can have advanced mechanisms for maintaining persistence, or you can ensure it in some other way, for example, asking the user to do some action that will make sure that the malware will stay there even after the system is being rebooted. So all step 5 does is to ensure that the malware, the weapon you delivered, is installed and maintains persistence into the system. And persistence, there are different ways to ensure persistence. One would be hooking, that whenever an API is called, for example, in Windows, you may call a function to open a file. That's a system call. What a malware can do is to intercept that, like a rootkit, and then once you open a file, it checks whether it's a special file and will do something different to that file, because before it goes back to what the operating system would have done anyway. Or when you have an API call on Windows that lists the directories of a file, the files of a directory, then you would try to hide the files of the malware itself. So when you're listing the files, you see, are my special files being listed? If yes, you just skip them and not deliver them to the graphical interface for presentation to the user. So hooking is what also rootkits do for persistence. Firmware would be another way to ensure persistence, where you change the firmware to install either a backdoor or some other kind of mechanism to ensure persistence. And we saw that in Triton attack. The previous hooking attack, what I described, was what Stuxnet did and how it hid itself from the drives and the hard disk. Firmware-wise, both the Ukraine attack had a firmware attack, and Triton changed the firmware of the Schneider Electric devices in order to have a backdoor for the attacker to use. Project file infection, Stuxnet did that. They changed the code of the Siemens PLC and installed malicious code that will stay even if the system is restarted. Valid accounts, if you steal the credentials of a user, then you can reconnect back even if the system is restarted. So you may have a connection, the system reboots, you have again the credentials, so you can connect back. Or you can create a new account in order to use it for entering the system again at a later stage. So now after step 5, the malware is installed and it's there in the system. However, there may be a need for the malware to be getting commands after installation, because after the malware is installed and stays in the system, it may be collecting information that is useful for the attacker for a next stage attack. So for the interaction between the malware and the attacker to take place, step 6 follows, that is command and control. So what command and control exactly means is that a compromised host, where your weapon was delivered, exploitation took place, and was installed in the system, then that malware can communicate back through the internet through another special server that is called the command and control server. So this, in a way, allows the attacker to have kind of a hands-on-the-keyboard access to the target environment, because they can send new payload or new malware to be installed, or they can do reconnaissance on the fly to be able to deliver some other form of an attack to the system. So the command and control center, in a way, is the defender's last best chance to block the operation, because the system may have entered, the malware may have entered and hopped from computer to computer and arrived to the machine that, for example, is controlling the PLC, but it doesn't know exactly what to do because that PLC has a very unique configuration. So to do something meaningful, the attacker has to know the exact configuration. So here is where the malware would send all the information back to the attacker. The attacker would craft new code and then send it back to the malware. But if you manage to stop that by blocking all outgoing traffic, for example, from the operational network, then you can stop the attack from doing something much more meaningful, as, for example, destroying physical equipment. And Stuxnet had a very advanced command and control mechanism. It did communicate on port 80 and send information over HTTP to two URLs listed here that were in servers located in Denmark and Malaysia. So Stuxnet, once it was in the system, it sent the system information out, and then the attackers had the chance to fine-tune the attack for the exact system that Stuxnet was located in, and then they would update the malware, so in order to perform the PLC attack that would damage physical equipment. The last step in the cyber kill chain will be the actions, action objectives. So once you're in the system and you have control over the malware itself, then you have to deliver on whatever your actions are, your objectives are, and that will be last step, step 7. That's up to the attacker's motives and intentions. It could be just exfiltration of data. Havex did that. It could be violation of data integrity and availability, or be compromising additional systems. Ukraine power grid attack, the electricity was turned off in specific sections of the country. In Stuxnet, equipment, centrifuges were damaged through this process. So the last stage, as we expected, would be doing the actions on the objectives themselves. So to conclude the cyber kill chain, we saw first step is to collect information and then use the information to create a weapon, and typically for OT that would be malware, deliver the malware to the system through USB or email attachments, and the delivery would trigger the exploitation somehow, either exploiting operating system or something else, and then the malware will install itself into the system for persistence and get commands dynamically from command and control to deliver on the objectives, which can be distraction or denial of service attacks on the systems themselves.